All right, so today we have Steve Wilson, Chief Product Officer at Exabeam, and an O'Reilly author. His book is called The Developer's Playbook for Large Language Model Security. He also does work with OWASP, and for our listeners who are not familiar with OWASP, it is, I guess, an industry coalition around open worldwide application security, uh, and they do a lot of good work. And most recently, they have a report on large language model applications and agents, which we will try to cover in this podcast. So, with that, Steve, welcome to the podcast.
Hey, thanks a lot for having me, Ben.
And so let's start out by setting the stage for our listeners. So I guess now that AI tools are much more accessible to everyone, unfortunately, including to bad actors. So what makes LLM and agentic AI security, in your mind, Steve, fundamentally different from traditional software security? So now that we've democratized these tools, so how do these tools raise the stakes?
Yeah, I think there's two parts of it. One is when you start to build software using AI technologies, you've got a new set of security things you have to worry about. And that's really the big topic of the book. And a lot of these vulnerabilities sound similar to traditional software vulnerabilities. We use words like injection, but something like prompt injection in AI, when your software is so smart that it's getting to near human level smartness, it's subject to the same issues that humans have, which is it can be tricked and deceived. And we see cybersecurity attacks on your software that look more like phishing than traditional hacking. The other part of it that is interesting to get into is what are the bad guys doing when they have access to frontier class AI, and how are they using it in novel ways, which is just getting to be crazy.
So in your work at OWASP, you guys have this top LLMs, the top 10 for LLMs, right? So, which has become kind of a great resource for teams. So, if you take that list, so what would you say are the top 1 to 2 risks that you see are causing the most immediate problems, or maybe the problems that teams underestimate?
So I'll give you the top three off the list. I think this is in order, but the first one is the one I mentioned briefly, which is prompt injection, which is this idea that by feeding data to the LLM kind of as part of the instructions, that you can trick the LLM into doing something that the developers didn't intend. Um, the next one of these is really the supply chain overall. The AI supply chain is much more complicated than the traditional software supply chain. And so not only are you dealing with things like open source libraries from GitHub and things like that we've sort of been learning how to deal with the security issues that could be there. You're dealing with you know gigabytes of model weights and terabytes of training data, and you may or may not know where those are come from and what is the provenance. And so these new sites that have grown up like Hugging Face, where these things have been hosted, we see lots of cases of malicious models that are uploaded there, hoping that people will bring them down and use them. And the last one that people are really focused on is sensitive information disclosure. These bots are not good at using their judgment about what they should talk about and what should they not talk about. And when you want to put them into production and give them access to important information, which can help with productivity or define new product features, you run the risk that they're going to disclose that information to the wrong people. And so with all three of these, just as examples, you need to rethink the architectures of your software. What are the techniques you're going to use to test it, and ensure that you don't run into these problems?
So let's take a couple of these. So the first one is the supply chain security, right? So, uh, uh, I mean, anyone who's worked in Python knows that whenever you install something, pip install langchain, it installs, I don't know, 50 other libraries that you have no idea, uh, you know. for anything ranging from NumPy to some library for PDF extraction, right? So a ton of dependencies. And then also, this is occurring at a time where, as I mentioned, everything is democratized. So people who may not have been using Python before or may not have been hardcore coders before now can do a little bit on their own, right? So supply chain security is a problem. So what can people do about it? What
All
are
right.
some concrete things?
Yep. So I think there's two flavors when you think about it. One is I'm building software that includes use of a large language model. And, so for example, I want to go and I want to go get Llama from Meta as one of these components. And that could be gigabytes worth of seemingly random floating point numbers. And how do I decide that I have a good, legitimate one of those? And so I think there's a real set of skepticism you have to put around what's the source of what I'm getting. Am I getting it direct from the source? Do I know the provenance of the AI models that I'm bringing into the system so I don't get something that's got problems in it? The other one that you mentioned is kind of this very hot topic right now that I think traditionally we've called things like AI aided software engineering, but somebody named it vibe coding
Vibe
a
coding.
few
Yeah,
months
yeah.
ago, and Andre Karpathy, who used to be with OpenAI, and yeah, it's absolutely true. Either people who've never programmed before, or maybe people who hadn't programmed in 20 years, who went down a different track, are all of a sudden coming back into these environments. And some of the problems that we describe in the book are things like large language models have a propensity to hallucinate, which means they kind of got some facts wrong and they kind of guessed. And you see this with generated code. We've seen a lot of examples where they will make up the existence of a software package. Like in their head, it's like, it's pretty plausible there should be a package that does the thing I want to do, and it's probably called this. And so they'll write code that goes ahead and imports that. And we've seen hackers that have gone out and started to look for the commonly hallucinated packages and create them and make malicious versions of them and put them on GitHub. So, the good news is it's not a completely novel problem, but it's one that a lot of people are not used to thinking about. And I think one of the things is that as an industry, as we acknowledge that our ability to generate code has gone up by 10x or 100x in the last 12 months, our ability to quality check and security check this code has not kept pace. So, what I'd say is for people starting today, go off and get some basic awareness of the concepts around application security and what does it mean to manage a supply chain. At least get a picture of that. The other thing is industry wide, the tools vendors are starting to catch on to this, but we need a different generation of software composition analysis tools that are designed to work with vibe coding and integrate into environments like Cursor rather than the tail end of a big CI/CD pipeline somewhere where things only get tested at the end.
And I think, especially this is true, I think, Steve, for novices, right? So for people who are not familiar, for example, with the Python ecosystem, they think, okay, I need something to do X. But in the Python ecosystem, there might be 20
Oh yeah,
options for doing that, right? So, and as you alluded to, now that there's 20 options, why not add a 21st if you're a malicious actor, right?
yeah, and I think we have good basic guidelines with humans where if you really go look at the packages you're importing, does it have a lot of stars on GitHub? Does it have a lot of users? Does it have a lot of downloads? Those are at least indications that you're getting something that's well respected. But really, what's professional developers do is use tooling, and they go off and get things like Sneak and SemGrep to run against their code to augment that. Those automated tools, we really need to bring those into this vibe coding process and make that just as easy as generating the code.
So, What's your sense of the maturity of what people are terming guardrails, right? But guardrails, there's, I guess there's two main kinds, right? So there's the input guardrails, right? So the guardrails where, okay, so this employee is submitting something on the prompt which they shouldn't be, right? So some proprietary information. And then, as you mentioned, there's the output guardrails on the LLM side. So what's your sense of the maturity of the guardrail tooling?
Yeah. Um, I think the good news is the ecosystem around guardrails started really soon after ChatGPT came out. I mean, I think it became so apparent, especially with the publication of the OWASP top 10, that things that were at the top of the list were prompt injection and um, and information disclosure. And that just led to the idea you need to map the trust boundaries around your LLM, which are all the data coming in and all the data coming out. And you need to be policing that because the LLMs themselves are not good judges of this. So I would say the good news is there's become a really expansive ecosystem.
Yeah, yeah. There's open source projects, right? So yeah.
There's both commercial projects, some of them from multi-billion-dollar cybersecurity vendors now, as well as open source projects, and then there's APIs direct from the frontier model providers. You can go into the open API set, and there's basic guardrails there. So one of the problems is you just have so many choices. You've got to figure out what to do. But what I'll say broadly, you asked about maturity, is we're still very much figuring out the science on how to have good guardrails for input. I think everybody wants to be able to wave a magic wand and say, I want to just put something here and make prompt injection not be a problem. And it's too hard. Counterintuitively, the smarter that the models get, the more problems they have with prompt injection. When you think about it, when we added the ability for models to see images, you can send prompt injections through images. I've seen people send them in emojis. We've seen people send them in foreign languages. The idea that you could just put a regex that says, please look for these bad terms, it's just way beyond that. So there is some really good science and research going on there. But it's still a challenge. And so what I tell people is put in guardrails on the input, but assume they're going to fail sometimes, which means you need another set of guardrails on the output. And you need to look for certain output types, certain types of data that you don't want to disclose. And that kind of gives you another pass at keeping things locked down. The last one, though, is don't give access to certain types of data to your models if you're not sure it's safe. And there are a lot of cases where a product manager could come up with a great use case, but you've got to look at that and say, am I really able to do that right now? I could demo it because it's easy to build, but could I really put it into production and know it's going to be safe is a different question.
Speaking of access, right? So a lot of times when we talk about AI these days, we're talking about the foundation models, right? But
Mm-hmm.
actually, as you are aware of, since you worked on the OWASP list, a lot of people are not actually building foundation models; they're building applications on top of foundation models. They're doing post training, and so one set of tools that people seem to be very excited about is the ability of these models to connect to different tools, data sources, and so on and so forth, right? So I guess MCP, Model Context Protocol, which is in many ways great, but when you think about it, this is another this is another vector. And how do I know that this MCP server is sufficiently hardened? There's not a lot of vetting right now, as best I can tell, Steve.
Yeah. It's interesting. We had one of the top 10 vulnerabilities on the first version of the list that we put out in 2023 was what we called insecure plugins. And at the time, OpenAI had just introduced a proprietary plugin standard that was full of security issues. it kind of died off as a result. And in the 2025 version of the list, we took that out. And then as soon as we did that, MCP shows up and, kind of brings all these issues back. But
There's thousands of these servers, right?
yeah,
Yeah,
because the good news is, like, let's look at the positives about
yeah.
this standard is they're pretty easy to build and build something that can be pretty capable. And when you look at what people are doing with them, it's great. But fundamentally, my favorite vulnerability on the OWASP top 10 list is what we call excessive agency. And everybody's building agents, and that vulnerability's been there since 2023, when people were not. It's this idea of how much responsibility am I giving to the LLM? LLMs are brains, and then we gave them mouths so they could talk to you. But when you give them fingers, there's a whole different level of things that they can do. And there's a fun chapter in my book where I talk about science fiction examples, and it's like, hey, in 2001, why could Hal turn off the life support system on the spaceship? Because the product manager said that was a good idea, and he never should have been able to do that. So there's a first question of, as I build all these tools and I give these tools to my AI applications, is that a good idea? Do I know how to lock that down in a way that it's only going to be used in a safe manner, sort of in line with what I've intended? And then does the protocol itself, really support secure usage? And, I think there are these two protocols that have come out really recently. One is MCP. The other one that's gotten an incredible amount of press just in the last few weeks is Google's A2A, which is how
Yeah, yeah.
talk to each other. In the security community, people are just really getting their teeth into that and coming up with the list of issues. The thing I love about the community is they're digging into that. They're finding these issues that lets the developers of those protocols hopefully rev those things really quickly. But I would say, as somebody considering building these things into the software, I would just want to make sure that I really understand how these protocols work, how they are getting attached to tools, and what are the potential things that can go wrong, because there are a lot. But when you see the capabilities it's going to bring, there's going to be a lot of demand for it. So I think you want to be experimenting with this really actively right now, but just look to understand it from both ends, both what's possible, but also what are the risks associated with it.
So, at the risk of dating you, so are there lessons, Steve, from web security, like HTTP and HTTPS, that can map over to this MCP world? And are there, so right now, obviously, a lot of it is based on trust, right? So you stand up on MCP server, you're Steve Wilson, I trust that that's a good server. But honestly, a lot of people are moving so fast, it's almost like security is an afterthought, right? So I need an MCP server for this. This is the only one that exists. I'm going to use it, right? So
Yeah.
without any regard for security, right?
So it's pretty easy to date me at this point because I have been around the block with this stuff. And you think back to the early days of the web. I mean, go back to dating not me, but dating my dad. The internet was built without any considerations for security, right? IP's never really thought about security. It was built for open access, right? The original thing was built for, I have information to share and people want to get a hold of it. And that was what it was built for. And
And that's where we're at right now for MCP.
Right.
Yeah, yeah.
And that's the way these things always start is developers never understand security and they kind of don't want to. So what I will say though is kind of the lesson from the early internet days, and that was with IP itself, and then HTTP, and then things like Java, which I worked on in the early days at Sun. Security was kind of always a bolt-on, even if you had some blush at it. And certainly, as we've gone into this AI era, security has been a bolt-on. the thing I would say, the sort of excitement I would see going forward with the ability to learn from these is, I don't know, at some level, people who develop software don't think the security is fun, right? And maybe it's not, and that's always been the reason it gets ignored. For some people, it's fun, and we love those people, but for a lot of people, it's not. In this world of the AIs starting to help us develop code more and more, we're now figuring out reinforcement learning for coding agents, which is why these coding agents are getting dramatically better at building code. I mean, just rapid acceleration in the last 12 months because we figured out how to do reinforcement learning and build reasoning models like O1, O3, O4.
Yeah, and then now we're starting to see companies build tools that will make reinforcement fine tuning accessible,
Yeah.
right?
And I think that the opportunity here is for us to build the same way that we're building code generation agents that think it's fun to generate code. We can build security agents that thinks it's fun to do security, and they're built that way, they're bred that way, and that's their whole job, and we put those into the development process and start to really shift left in a way that we just never were able to with the last generation of tools that were just not, they didn't fit well into the development process, and so development teams would fight them. If we can really make the AIs do it, and I'm seeing a lot of really quality early work in that direction, some from startups, some from groups that already existed. But I think that's a really exciting opportunity, and that's the lesson we can learn is let's build it into our stacks to do security and not just depend on everybody learning a better way to do this.
I think we'll have to, right? So, and by the way, I'll drill down further on this AI for security as opposed to securing AI later on in the conversation, and also on agents. But before I go into agents, a quick question. You mentioned hallucination earlier, right? So for people listening, is hallucination an annoyance, or should they treat it as a security threat?
Um, Hallucination is a big threat and a massive gift. We often talk about or debate the idea of, are these AIs ever going to create original works? Or are they just parroting back things that they heard? And I'm pretty much in the camp that they're already generating original things, and it's kind of the fact that these are not fully predictable systems. And so they do go off and do things that you didn't quite ask for. And that's wonderful. And when you see them generating art or really elegant code in places, you're like, that's better than I would have done. But on
By
the
the
other
way,
hand,
Steve, just to let our audience know, hallucination can also occur even if you have RAG. So just because you have RAG doesn't mean the agent won't hallucinate. Some people think that hallucination is only with the model itself, but
yeah.
no.
Well, let's talk about the nature of hallucination, because I try to explain it this way, and we'll link in the RAG piece as well. But I think people who are used to traditional software are just puzzled by the fact that hallucination happens. You're like, software either does the job well or it doesn't do the job well. But these things are more like humans, and they do what we train them to do. And what's interesting is, like, when you think back to being in school and the teacher asks you a question, what do you do if you don't know the answer? You've been trained to try and give the best answer. They're like, come work this problem on the board. You go try your best, and you might just get it wrong. And the same thing happens with LLMs, where if we ask them something that they're not well trained on, they might get the wrong answer, but we've trained them to give answers.
I refer to them as PPs, probabilistic pleasers.
Yeah. And but I think the thing is, when you really view it as when we're always giving the LLMs closed book tests, that really makes the guessing problem really exacerbated. And so RAG, retrieval augmented generation, the idea that you could give some relevant data to the LLM before it answers, that dramatically increases the probability that they give you a good answer, but does not fully solve the problem either. And for a few different reasons. So I think understanding that these things are not fully predictable systems, that they are not binary right or wrong, that you might get different right or wrong answers from them on different days. Understanding that as a software developer and sort of building systems defensively to know that that will happen is really important. So you want to arm your system with as much of the right information as you can. And what I've found is when you do RAG really, really well, you can get very high percentage results from it. But it's still a bit of an art to do that well. And a lot of people are doing very simple RAG things where you take all your PDFs and you throw them in a vector database. It's better than nothing, but that's not the really handcrafted way to make sure that they're getting the best information to make the best answers.
So let's talk a little bit about agents, because the OWASP report focuses specifically on agents, right? So we're talking the introduction of agency, things like planning, memory, tool use, I guess, autonomous operations in general. So let's set aside multi agents, because I think they're a bit of a science fiction right now. I mean,
For sure.
I, I like them. I mean, I am chairing an agent conference, and I'm very bullish on them. But I think uh, there's some papers that have come out that kind of tell me that let's focus on single agents for now. So let's set aside multi agents, or if you want, you can go into multi agents. But so agents in general, aside from LLMs, what should people be the most concerned about agents as far as security?
Yeah. So I think there's a few qualities about these things. What makes something agentic? I think people want to say, well, did you implement the agent interface? It's like that's not what it is. There's no universal standard for what's an agent. It's like agentic qualities. And one of them is that these things are they're more active, they're more proactive, they're capable of carrying out actions and using tools. So we've touched on some of that. And so when you see the vulnerability specific to that, when you assume that you have tool usage, it brings in a whole new area of things to worry about. Both sort of the excessive agency. If I give it power tools, does it know how to safely use a chainsaw? Or is that a good idea? Or should I maybe back that up and give it a butter knife? Then there's are the tools attached to the agents in a safe way, or are there ways to get in the middle of that flow? And I think that's what we're seeing with some
The
of
human in the loop, right? So
yeah. But then some of the things that we see are with better reasoning, and the new models have so much better reasoning that they did. They're now able to do more multi-step processes. We used to talk about these things as kind of one-shot, two-shot things, because after a little bit, you couldn't have a coherent conversation with the LLMs. They'd get distracted and they'd forget the beginning of the conversation. Now you can have agents that are trying to carry out much longer term things and loop back on themselves and correct themselves. And one of the things that means is when we talk about these vulnerabilities like poisoning, we used to talk about training data poisoning. And the thing about training data poisoning is, for the most part, in an LLM world, that was not your problem. It was a problem for somebody building a foundation model, or maybe
yeah.
if I was doing fine tuning, which most people don't, I needed to worry about it. But now you have things like memory poisoning, and it's like if I can inject something into the system, not only can I prompt inject it because it's an LLM, but that injection could be persistent for a long time while it's working on a long running task. And that's a different consideration.
All right. So then let's see. One of the things that is actually quite glaring in this space, right? So in traditional software, I hope most companies have incident response playbooks, right? So
Hmm.
But in AI, I don't think many teams have AI security, AI incident playbooks at all. I don't think teams actually have sat down and decided what's an AI incident. You know what I mean? Which is step number one.
Yeah. So, there are a few things. One of the pieces of literature or pieces of research that we put out from the OWASP team recently was very specifically one kind of guide for response, and it was one that we were getting asked a lot about, which is how do I respond to a deep fake incident? So it's basically the offensive use of cybersecurity, and how do I respond to those incidents? And there's a really nice guide out there on the site, which is just genai.owasp.org. The other thing that we put out from that team that I really like is we have a document on building an AI center of excellence inside your company, and in particular for AI security. I mean, a lot of people are building AI centers of excellence in general, but really building that AI security expertise inside your company where your security teams and your executives start to understand the risks associated with security. And by having a COE, you can then make sure that you are building out response plans and playbooks and things the way that you did for a traditional incident like phishing. What do you do when you're attacked by AI or when your AIs are attacked? These are new classes of things where they're probably not completely distinct playbooks, but you need to augment the playbooks you have in your SOC to deal with new threats and new vulnerabilities.
Yeah, yeah, and the thing about where we're at right now is the fact that things have been democratized. You can take um, teams and they can build interesting prototypes. I mean, I'm here when I say teams who are not coders, right?
Yeah.
Build interesting prototypes, and then they may become much more kind of aggressive in terms of let's roll this out, and and the reality is, I think a lot of these prototypes probably don't are not robust enough to be rolled out. They fail even basic eval when you push them, um, and then obviously there's this problem of what happens when things go wrong. People don't think that through, right? As you mentioned, actually. So with incident response, step number one, what would we define to be an incident, and number two, what's our containment strategy?
Yeah.
You mentioned this earlier, right? So containment. So people don't think this through.
It's interesting. I mean, sometimes it helps to just go back and look at the past and past generations of these things, because it's easy to get caught up in this vibe coding thing and say this is the first time it's ever happened, but it's not. We've seen things that just rhyme with this so closely, and you think back to a previous generation and you think about tools like Visual Basic, and there was a time when it's like, wow, that just presented this whole new class of um, we sometimes we called them citizen developers. That was the buzzword. It's like, hey, you don't have to have a CS degree. Just grab this tool and start dragging and dropping, and we wound up with hundreds of crazy applications built around the enterprise without a lot of oversight. And then we wound up with things like putting Visual Basic into Microsoft Office, where now it was like every spreadsheet was a programming environment with an attack surface, right? And that's why you can't open things
Yeah,
with
and then
emails anymore, is
not
because
only that, people can record their macros, so
yep.
they're not even coding, and so then suddenly now there's
So that was like the 1990s version of vibe coding, and we all survived it. That's the good news, but it was a bumpy path for a while there, where like around every corner you were looking for some virus that was going to come get you, that somebody built on these things. And so I think the thing we know is these new generation of tools are going to be really attractive. They are, as we speak, enabling a new generation of citizen developers, if you want to call them that. We not call them vibe coders, but we're going to see a lot of that. The interesting thing is that like that Visual Basic ecosystem and things that came after it. We've had lots of rad tools over the years. They tended to live in these little boxes with these little runtimes because that's how you got them to work. Now they work in every programming environment in every language. And they're not boxed in the same way. They can look at first blush like any professional project out there. And so it's much harder to spot the weird guy. And that's what's interesting is people are out there building businesses on these all of a sudden and then running into trouble, or deploying them in the enterprise and people looking at them not as a weird citizen developed thing, but as a production system. And so I think, what I hate with the security community, which I consider myself part of, is when the security community gets on their high horse and tries to gatekeep things and make fun of the people trying to use these tools. And I see too many memes with Batman getting slapped and things like that, where they say, "You silly vibe coder." Instead, we just have to acknowledge that this is a 100-fold increase in our ability to create software. And as a security community, we can't be making fun of these people. We need to be helping them. We need to be, put our community at its best. It is the community that knows how to find threats, keep people safe, make things better. If we can do that for this new generation of AI-assisted software coding, we're in for a golden age of software development where anybody can build custom software to do whatever they want. And you're not beholden to the same group of megacorps who are the only ones that get to build software. I think it can be amazing, but we've got some work to do to get there.
So I have to come clean. I might be guilty of the reverse, an AI person making fun of security people in some ways, because every year I walk around the expo hall at RSA, and I just get so confused. Everyone is using the same buzzwords, right? So we're using AI and this and that. So you go to the booth and then you go, "This is not AI." So Steve, give us a very quick overview of the state of AI being used for security. So
Yeah.
what's sort of the most real things to you right now? The most usable. Yeah.
So the first thing to look for is the places where people were really using AI before ChatGPT. And so when you look at things like, it's a clunky acronym, but there's this thing called user and entity behavior analytics that's been around for about 10 years. And it's the idea that, inside what's called a security operations center, you're collecting billions of log file lines every day. And a security team wants to look at them and look for threats, insider threats, compromised credentials.
Yeah, usually some analyst tool, right? So analyst is still in the loop, right?
Right. And the analyst traditionally is searching through these millions of lines, building brittle correlation rules, trying to find needles in haystacks. So with user and entity behavior analytics, you can build these machine learning models where you model things, and they're not simple rules, they're complex distributions of what does Ben do on a given day, and where does he log in from, and what does he touch? And all of a sudden, if you're on a different computer in a different country accessing different applications, I want to surface that and get it in front of a human operator and say, you might have a real problem with Ben here, or maybe maybe he's planning to leave the company and he's going to steal things, or maybe someone has stolen his keys and you got to help him. And that's really getting to be pretty robust and pretty mature. And so looking at those, that's not large language models, because you can't people are collecting terabytes of this information.
But you can have a language interface now.
Right. But now when you search, I don't have to search in query language anymore. I can search in English. That's Splunk. People learned, Splunk query language, and it was a core tenet of what they did. Yeah. But now you can just say, "Hey, find me the top 10 IP addresses sending traffic to North Korea from my network." It's like, okay, here you go. Got it. So that's great. The next one is really mashing this up with this new set of large language models. And the search interface, things like natural language search are a first one. The next one is really these security copilots and agents. And how do you take the output out of things like user and entity behavior analytics? And how do you augment that operator in the SOC trying to make that snap decision about, do I turn off the CEO's laptop at the investor conference today? Because I've got this indication that I think his account might be compromised, but I don't want to get fired. How do I sift through all this information and make a great decision? It's a great use case for an agent built on a large language model to look at that data, be able to do it faster and in a more complete way that the human can do, to come to a good decision, come to a well-founded decision, and ultimately reduce that mean time to response. And I think that's where this is going. But I think, when you're walking around RSA, you want to be looking out for the fact that, like we talked about with LLMs in general, and now especially with AI assisted software engineering, it's never been a better time to build a great demo of an AI feature. And people are out demoing outrageous things, but they may not really have the efficacy or deliver the value. And so I think what I tell everybody in the cybersecurity side of the house is, be deeply skeptical about these AI capabilities. They are real, and you will find pockets of them that are indispensable, and you want them in your environment, because now that the bad guys have it, you better have it or you're not going to catch up. But be deeply skeptical when you see this messaging where somebody's frosted AI enabled on the side of their booth or is showing this latest, greatest demo. How do you know it really is going to deliver you that efficacy and that value?
And so, in closing, Steve, I suspect many of our listeners are not familiar with OWASP. So, give us a pitch for why our listeners should listen to OWASP, and what should they look forward from OWASP in the months ahead in
Yep.
terms of AI security.
So broadly, OWASP is a group that is more than 20 years old. So it's not a group about AI. It's a group about producing secure code and secure applications. And, we started 20 plus years ago on the back of a project called the OWASP Top 10, which was just meant to be a simple educational tool for, here's 10 things to look out for when you're building your first web application. And unfortunately, a lot of those things are still with us, but at least people are educated on them and can learn to address them. About 2 years ago, when we looked at ChatGPT, we realized there was this whole new set of security things that nobody had really organized and documented. So we put together a group to really attack that problem in a dedicated way. And we came out with the top 10 for large language models. Honestly, when I proposed creating that group, I thought I'd find 10 people in the world who were interested in this weird corner intersection of AI and cybersecurity. But I had 200 people volunteer to be on the expert group in the first 48 hours. And we've produced several versions of these documents in the last couple of years that have been downloaded hundreds of thousands of times. Most recently, though, we've started branching out from just that top 10 list, producing guidance on how to build agents and how to do red teaming and, all sorts of related topics that are not just lists of 10 bad things, but really guides on how to get better. And so we've just rechristened the project as the OWASP GenAI Security Project, with all of these new documents that we're producing. And so we're going to be at the RSA conference soon. We're going to have a big event at RSA that anybody can come to and learn about AI security stuff. And, it's an exciting time, but I think OWASP, it's totally nonprofit. It's totally volunteer driven. It's basically an open source community that's centered on building tools to make things more secure or educational materials. And, it's a great, easy way to go hop in and get involved.
And given that the space is moving so fast, you folks will need to kind of also produce material on a regular cadence.
Yeah, I mean, it's one of the things that I think really wound up being a strength of OWASP in this case, is given it's more of an open source project than a standards body. The traditional cybersecurity places where people have gone for this information, like MITRE and NIST, they're NGOs or actual government agencies. Uh, Even before any current funding issues with those, they just move slow. They build things on years timeframes, and we decided to work in timeframes of weeks. It's let us get out guidance really, really quickly. But given that it's not just one person's opinion, and we have lots of people involved and lots of vetting, we've produced really high quality things people like.
And also, you get feedback.
Yeah, all the time. And we're on our third rev of the top 10 list, and many of these other documents we're producing second or third versions of as well. So it's evolving all the time and pretty quickly.
And with that, thank you, Steve.
Hey, thanks a lot, Ben. I appreciate you having me on.